Hi, hello everyone. Welcome to SK Academy of Mathematics. Today, let us learn how to solve the problem on irrotational and scalar potential, where scalar potential is also known as scalar function, where we are going to find the function phi with respect to the vector f. Considering that, first we are going to find the value of constant term a by representing it into irrotational form. What does irrotational form represent? Irrotational form represent curl f vector equal to 0, then we call it as irrotational. After whatever we get this solution, then we are going to find the scalar function phi with respect to vector f equal to gradient phi. How to solve, how to represent? Now let us see. First, let us find the constant a with respect to irrotational. To find irrotational, we have the curl vector f should be equal to 0 to get irrotational condition. What does curl vector f represent? Curl vector f represent I, j, k determinant of then dou by dou x, dou by dou y, dou by dou z. F1, F2, F3. Now let us represent vector F which is equal to AXY minus Z cube I cap plus A minus 2 X square J cap plus 1 minus A xz² k cap, where f1 represent with respect to I, that is axy minus z cube, comma f2 represent with respect to j, that is a minus 2 x square, comma f3 represent with respect to k, that is 1 minus a xz². Done. Now substitute f1, f2, f3 in curl vector f, that is curl vector f which is equal to I, j, k dou by dou x, dou by dou y, dou by dou z. Now what is f1? We have axy minus z cube. Next we have a minus 2 x square. Next, last we have 1 minus a xz². Yes, we are going to do the determinant matrix multiplication. What? Determinant matrix multiplication. X square. At the point, now let us do the determinant matrix multiplication. That is, first, curl vector f which is equal to I into this, that is dou by dou y into 1 minus a xz². Then minus, next dou by dou z into a minus 2 x², minus, then with the what I, yes, no, minus j into this into this, that is dou by dou x into 1 minus a xz² minus this into this, that is dou by dou z into axy minus z cube. Done with j. Now let us go with respect to k plus k into, now this into this, that is dou by dou x into a minus 2 into x² minus dou by dou y into axy minus z cube. Done with the determinant matrix multiplication. Now let us differentiate term by term. Okay, that is curl vector f which is equal to, see, this is one term. Okay, we have, I need to differentiate this whole term with respect to y. In this whole term, does we have any variable y? No. If there is no variable y means, that means it has 1. Differentiation of 1 with respect to y is 0. Minus same in this term, in the whole this term, that is a minus 2 into x square, we don't have the variable with respect to z, so that I can differentiate. So this term again it becomes 0. That is I becomes 0. Done. Now minus j we have, let us go with respect to j. Now I need to differentiate this whole term with respect to x, but I have x, yes. So 1 minus a z square remains constant. Now differentiation of x with respect to x is 1. That's it. Okay. Minus. Now I need to differentiate this whole term, but we have two terms in this, that is axy minus z cube. So I am going to differentiate term by term. If you have multiplication, you can directly differentiate when it has constant terms. Okay. If we don't have constant term, if it is separate with respect to sign, we are going to differentiate term by term. In the first term, that is axy, we don't have z, so this term becomes 0. Minus, we have z cube. I can differentiate z cube with respect to z, that is 3z square. Done with the j. Now let us go with the k. K into, I need to differentiate this whole term with respect to x. So a minus 2 remains constant. Differentiation of x square, you get 2x minus. Now I need to differentiate this whole term with respect to y. First let us go with respect to term by term, that is ax remains constant. Differentiation of y with respect to y is 1 minus differentiation of z cube with respect to z y is 0. This is k. Now curl vector f, which is equal to 0I minus j into 1 minus a z square. Next we have 0 minus 3z square minus 3z square, minus into minus plus 3z square plus k into a minus 2 into 2x minus ax. Ax into 1, ax minus 0, ax minus ax. Now multiply the inner term, that is curl vector f, which is equal to 0I, I can neglect it. Then we have, okay, let us represent in the last, 0I minus j into, multiply 1 into z square minus a into z square plus 3z square plus k into, now multiply 2a x minus 2 2s are 4x minus ax. Done. Now curl vector f, which is equal to 0I minus j into, see, z square plus 3z square, you get 4z square minus az square. Done. Now similarly plus k into 2ax minus ax, you get ax minus 4x. Now curl vector f, which is equal to 0I minus j into, in this two I can take it as z square as common, z square as common plus k into, in these two I can take x as common, that is a minus 4 into x. See, but what is our main intention? That is to find the irrotational condition. To find irrotational condition, curl vector f whole term should be equal to 0. Based on what? The constant term a. To find constant term a, we have with respect to, in this I we have already 0, but with respect to j direction and k direction we have 4 minus a and a minus 4. That is both are same. So what I am going to consider? I am going to consider a minus 4 equal to 0, where the value of a equal to 4, by just considering this condition. Now, if I put a equal to 4, each and every term will be equal to 0. That is curl vector f, which is equal to 0I minus j into 4 minus 4 z square plus k into 4 minus 4 x. Everything get cancelled, you get curl vector f equal to 0. If curl vector f is equal to 0, then we conclude it as it is irrotational. Therefore, the given vector field is irrotational when a equal to 4. When a equal to 4, we have find the irrotational. Now this is the condition whatever we need to find the given vector field, that is irrotational. Got the point till here? But now we need to find the scalar function phi. To find the scalar function phi, what we are going to do? To find the scalar function phi, we have vector f equal to gradient phi. But first, before gradient phi, let us represent vector f. Consider, now let us find, we are finding scalar function. Consider vector f which is equal to axy minus z cube I cap plus a minus 2 x square j cap plus 1 minus a x z square k cap. Now I need to apply the value of a, that is put or apply a equal to 4. When a equal to 4, vector f which is equal to 4xy minus z cube I cap plus 4 minus 2 x square j cap plus 1 minus 4 x z square k cap. Vector f which is equal to 4xy minus z cube I cap plus 4 minus 2, you get 2x square j cap plus 1 minus 4, you get minus 3. So plus into minus 3x z square k cap. This is our vector f. Got the point? This is our vector f. Now I am going to represent gradient phi. What does gradient phi represent? Dou phi by dou x I cap plus dou phi by dou y j cap plus dou phi by dou z k cap. Got the point? Considering these two equations, I am going to represent the scalar function phi. How? Now let us see. First, consider vector or else gradient phi which is equal to vector f. What does gradient phi represent? Dou phi by dou x I cap plus dou phi by dou y j cap plus dou phi by dou z k cap, which is equal to, what is vector f? We have 4xy minus z cube I cap plus 2x square j cap minus 3x z square k cap. Now I am going to represent with respect to the direction, that is I with respect to x, j with respect to y, k with respect to z. Corresponding to this direction, we are going to represent the scalar function phi. How? Now let us see. Okay. Let us go with this step by step. That is, first let us represent the scalar function with respect to x. That is, dou phi by dou x, which is equal to 4xy minus z cube. Similarly, dou phi by dou y, which is equal to 2x square. Then dou phi by dou z, which is equal to minus 3xz square. With respect to x, y, z, and with respect to the direction I, j, k, we have represented. After this, what we are going to do to find the scalar function phi? What we have, we are going to integrate with respect to each and every variable with respect to on both sides. That is, consider dou phi by dou x, which is equal to 4xy minus z cube. Integrating on both sides, integrate with respect to x on both sides. Since we have dx, so I am going to integrate with respect to x. That is integration of dou phi by dou x, which is equal to integral 4xy minus z cube dx plus. Now, since I am going to differentiating with respect to x, I have, but I am not going to neglect y and z. So what we are going to do, I am going to represent it as f1 of y comma z. That is constant term I have represented with respect to the function f1 of y comma z. Done. Now let us integrate. See, differentiation integration get cancelled. You get the only the function phi. Now let us integrate term by term. 4xy dx minus integral z cube dx plus f1 of y comma z. Now phi, which is equal to 4y remains constant. Now integration of x, we have x square by 2 minus z cube remains constant. Integration of 1 with respect to dx, you get x plus f1 of y comma z. 2 get cancelled, 2 ones are 2 2s are phi, which is equal to 2x square y minus x z cube plus f1 of y comma z. This is the first scalar function after integrating with respect to x. Similarly, let us integrate with respect to y. That is, now consider dou phi by dou y, which is equal to 2x square. But I need, since first is integrated with respect to x, but here we have y. So integrate with respect to y on both sides. You get integral of dou phi by dou y, which is equal to integral of 2x square dy plus. Now since I am going to integrate with respect to y, yeah, now I am going to consider the second function where x and z remains constant. Okay, now see, integration and differentiation get cancelled. Again you get phi, which is equal to, since I am going to integrate with respect to y, 2x square remains constant. Integration of 1 with respect to dy is y plus f2 of x comma z, where phi, the second function is 2x square y plus f2 of x comma z. This is the second scalar function when you differentiate with respect to y. Now let us differentiate, consider this with respect to z and integrate. Consider dou phi by dou z, which is equal to minus 3xz square. Integrate z with respect, integrate with respect to z, integrate with respect to z on both sides. What you get? Integral dou phi by dou z, which is equal to integral minus 3xz square dz plus. Now since I am going to integrate with respect to z, x and y, that is function of x3 of f3 of x comma y remains constant. Now integration and differentiation get cancelled. You get only the scalar function phi, where phi, which is equal to minus 3x remains constant, integration of z square dz plus f3 of x comma y. where phi which is equal to minus 3x into integration of z square, we have z cube by 3, where 3 get cancelled, plus f3 of x comma y, where phi which is equal to minus 3x z cube plus f3 of x comma y. This is the third scalar function with respect to z. Now, consider this as equation 1, assume this as equation 1, assume this as equation 2, and assume this as equation 3. Now, considering all these three equations, I need to represent one scalar function. How to represent one scalar function? Based on the function of the constant term, that is f1 of y comma z, f2 of x comma z, and f3 of x comma y. How to find the scalar function? That is, it is very easy. See, compare all these three equations, check which equation doesn't have the another equation, just give that equation so that each and every equation gets satisfied. That is simple. First, let us see. First, I am need to find f1 of y comma z. Okay. Next, we have f2 of x comma z. Next, we have f3 of x comma y, so that it should satisfy the scalar function phi. Now, first we have 2x square y. 2x square y. Now let us check into the second equation. We have 2x square y, but in the third equation we don't have 2x square y. So what I am going to give? I am going to give 2x square y in the f3 of x comma y. 2x square y in f3 of x comma y. Done. Now similarly, let us go with it again. Repeat. Now first, in the first equation we have minus x z cube, but in the f2 we don't have minus x z cube, but we have minus x z cube in third equation. So there is only need of minus x z cube in f2 of x comma z, that is minus x z cube. If I give these two, it satisfies all three equations, but here there is no necessity of giving anything, so I am going to give it as 0, so that it satisfies each and every condition. That is, see, first 2x square y minus x z cube. See, if I give f1 of y comma z 0, 2x square y minus x z cube, you get this one. Yes. Now, if I give minus x z cube, it satisfies second equation. Yes. If I give 2x square y, see, 2x square y minus x z cube satisfies the scalar function. Yes. This is how we are going to find the scalar function of the given vector field f. This is the procedure of step by step finding the scalar function, which this is the one of the most important question where it carries 7 marks in VTU main examination. I hope you have understood this problem. To solve, represent, first we are going to represent irrotational, and then we have represented the scalar function, that is phi. If you want to verify the scalar function phi, whether it is correct or wrong, just if you differentiate with respect to x, y, z, you will get this function, that is this with respect to this. Just let us differentiate this phi just with respect to x, that is, see, if I differentiate dou phi by dou x, see, now 2 remains constant, differentiation of x, you get 2x y minus x differentiation is 1 z cube, you get 4xy minus z cube. Check, you get this. Say 4x5 minus z cube. This is how we are going to represent the scalar function and verify the scalar function. I hope you have understood this problem. For more videos, please do like, share and subscribe. See you in the next video. Thank you.